So after completion of the Raoult's law, derivation and applications, then we are going to discuss about ideal and non-ideal solutions. So then ideal solutions. So ideal solutions means a solution with two or more components. So there is a solution with two or more components. A solution with two or more components. This solution which obey Raoult's law. This solution which obeys Raoult's law. Okay, which obeys Raoult's law at all concentrations and temperatures. At all concentrations and all temperatures is called ideal solutions. Okay, so it is the ideal solution. So ideal solution means a solution with two or more components. This solution which obeys Raoult's law. When at all concentrations and temperatures is called ideal solution. So this solution is known as ideal solution. So now it is explained with one suitable examples. For example, let us consider liquid A. So this liquid A, simply it is considered as a solvent. So then liquid A combines with liquid B. So the liquid A combines with liquid B. So then it gives liquid AB. Okay, it gives liquid AB. So now the obtained liquid AB act as ideal solution, behave ideal solution when generally in liquid A with some molecules. So then liquid A, so now AA molecular attractions, AA molecular force of attractions, AA. What is AA molecular force of attractions, molecular force of attractions, AA molecular force of attractions are equal to BB. What is BB molecular force of attractions, BB molecular force of attractions. So then liquid A combines with the liquid B, it gives a liquid AB. So then the obtained liquid AB behave as ideal solution when, so in liquid A, AA molecular force of attractions are equal to BB molecular force of attractions, BB molecular force of attraction. Then what happens? These AA molecular force of attractions or BB molecular force of attractions are equal to AB. What is? Are equal to AB molecular force of attractions. Force of attractions. So then the obtained liquid AB behave as ideal solution. So in the formation of the solution, so then delta H. So H is the enthalpy, delta H is the change in enthalpy. Delta H mixture is equal to 0. Delta H mixture is equal to 0, and also delta V mixture also 0. So now the obtained solution behave as ideal solution when the mixture change in enthalpy becomes to 0, mixture change in volume becomes to 0. This solution behave as ideal solution. What is an ideal solution? It is simply ideal solutions. So ideal solutions means a solution with two or more components. What is two or more components? This solution obeys Raoult's law at all temperatures and concentrations is called ideal solution. What is ideal solution? So for example, let us consider liquid A. It is mixed with the liquid B. It gives a liquid AB. So it is a solvent, it is a solute, it is the solution. So now the obtained solution behave as ideal solution when now the attractions between molecular force of attractions between AB, molecular force of attractions between AB is equal to AA molecular force of attractions or BB molecular force of attractions. It means simply, so then AB force of attractions between AB is equal to AA molecular forces or BB molecular forces. BB molecular forces, then the obtained solution behave as ideal solution. What is a ideal solution? So generally ideal solutions explain with respect to partial pressures. Ideal solutions explain with respect to what is a partial pressures. So now let us consider a solution with two components, a solution with two components. So wherein A is the solvent, that is A is the solvent and B is the solute. What is B is solute. A solution with two components, A is solvent, B is solute. Now generally, so then PA is, what is a PA is partial, it is the partial vapor pressure of solvent, partial vapor pressure of solvent. So then PB is the partial vapor pressure of solute, partial vapor pressure of solute. PA is a partial vapor pressure of solvent, PB is a partial vapor pressure of solvent, solute. So then PA plus PB equal to PT. So then PT means total pressure. So then what is it? Total pressure equal to PA plus PB. According to Dalton's law of partial pressure. What is Dalton's law of partial pressure? The mixture of partial pressures, the sum of the partial pressures are equal to the total pressure. So then total pressure equal to partial pressure of solvent, partial pressure of the solution, partial pressure of the solute. Total pressure equal to partial pressure of solvent plus partial pressure of the solute. So then let us consider PA. What is PA? PA is the partial vapor pressure of solute equal to P naught A into XA. P naught A into XA. What is P naught A? It is the vapor pressure of pure solvent. XA is the mole fraction of solvent. Same as PB, partial pressure of the solute equal to P naught B into XB. P naught B into XB. XA is with respect to mole fraction of solvent. XB is mole fraction of solute. Mole fraction of solute. So then PT equal to what is PA plus PB. So then PT equal to PA plus what is PB. So then equal to what is PA? PA is P naught A into XA plus P naught B into XB. What is P naught B into XB? So according to Raoult's law, According to Raoult's law, total vapor pressure of the solution, is P naught A into XA plus P naught B into XB. So then it can be written as simply, so then P naught A plus XB into P naught B minus P naught A. What is P naught A? So then P total equal to PA plus PB equal to P naught A plus XB into P naught B minus what is P naught A. So generally in this representation, pressure and mole fractions are present. What is pressure and mole fractions are present. Now this representation is explained with the help of the graphs. So generally a graph drawn between, a graph, what is graph drawn between partial vapor pressures to the mole fractions. Partial vapor pressures to the mole fractions. So then partial vapor pressures to the mole fractions. So then partial vapor pressures are taken on the y-axis and mole fractions are taken on the x-axis. Mole fractions are taken on the x-axis. So it is the graph. A graph drawn between partial vapor pressures and mole fractions. So then mole fractions are taken on the x-axis. These are the mole fractions x, and these are the partial vapor pressures. These are the partial vapor pressures. Partial vapor pressures. So now the graph drawn between mole fraction and partial vapor pressures. So now let us consider. So then it is the P naught what is A? P naught A. So then P naught A with respect to x-axis. P naught A with respect to x-axis. So then it is the P naught B with respect to y-axis. So then now PT equal to, it is PA plus what is it is PB. PA plus PB. So total pressure is represent the linear reflection. Mole fraction also linear reflection. It is P naught A with respect to PA. It is P naught B. It is with respect to PB. So it is the graph drawn between mole fraction and partial vapor pressures. Now generally the solution which obeys the ideal behavior when the liquid with similar chemical structures and polarity. So then chemical structures and polarity of the liquids are same. It is act as what is ideal solutions. So now example of the some ideal solutions is, so the mixture of benzene C6H6 benzene and C6H5CH3, it is the toluene. Benzene toluene, best example. So now second example is N-hexane and N-heptane. It is the N-hexane plus N-heptane. N-hexane and N-heptane. So third example is ethyl bromide C2H5Br plus C2H5I. So these are the best examples of the ideal solutions. So what are benzene plus toluene, N-hexane plus